morning. I apologize for not being here today. Please, as we talked about last time, please be on your best behavior for your sub, Mrs. Taylor. Remember that if things get to the point where she has to write your name down, you can expect a detention when you return, when I return. So please do be on your best behavior. What I'd like you to do is I'd like you to get out your notebook, turn to these notes we took yesterday. There's kind of a front and back. There's work and energy. And then the thing we're going to spend most of our time with today is this page. So remember, we've talked about work as the product of force and distance. We talked about how in math the word product means multiply. So the equation is work equals force times distance. We've talked about how we measure work and energy with joules, and we've talked about how the energy is the ability to do work. And we've specifically talked about how there are two types of energy: kinetic energy, which is the energy of motion, and potential energy, which is energy that's stored. And there are 4 different types of potential energy that we have discussed. Today I want to focus on the math involved in kinetic energy and potential energy calculations. And so you're going to have this page of your notebook open on your desk because you're going to be able to use that when you're solving the problems that are on the packet that you have. So what I'm going to do here is you should have this packet. I am going to do warm-up A and warm-up B with you, just to remind you how to do this. And then your job today is going to be to do problems 1 through 6 on your own. So let me go through warm-up A and warm-up B with you and show you how you can use this page of your notes as a guide. All right, warm-up A, let's read it. How much potential energy does a 6.2 kilogram bowling ball suspended 8.3 meters above the ground have? All right, so the first thing we do always when we're doing these sorts of problems is we do knowns and unknowns. And the reason that we have this page is to kind of help us figure out what the knowns and unknowns are. So we can identify our numbers here, our measurements, and we can use this table in our notes to determine which known and unknown it is. So when it says how much potential energy does a 6.2 kilogram bowling ball have, well, we can say, what is kilograms? Well, if I look at the units, kilograms here is a measure of mass, m. So my first known is that mass is 6.2 kilograms. All right, it's suspended 8.3 meters above the ground. So what's 8.3 meters? Well, we have 2 options. Meters can either be a distance or meters can be a height. Now, which one makes sense in this case? It says 8.3 meters above the ground. So if it's above the ground, we're probably talking about a height. So we can say here that our height is 8.3 meters. And what are we looking for? It says we're looking for potential energy. What's the symbol for potential energy? Potential energy is PE. All right. So now we're ready to do our plug and chug. So let's pick an equation. So if I want to find PE, there's only one equation I can use, and that's that one. So I'm going to write PE equals mgh. And I'm going to start plugging in my numbers. So my m is 6.2. Uh-oh, what's my g? We didn't write g down. The problem didn't give it to us. What do we know? Well, as we talked about yesterday, or as we talked about on Tuesday, and before break, we have little g, which stands for the acceleration of gravity. It's always, when you're on Earth, the same number, 9.8 meters per second squared. So I can actually put that over here. G is 9.8. So that's my g. And then my height is 8.3. So now I get out my calculator. 6.2 times 9.8 times 8.3. Oops, I got an issue there. I didn't type that in right. 6.2 times 9.8 times 8.3 is 504.31 rounded to 2 decimal places. All right, and then we got to give our answer with units. So this is a potential energy. We could check potential energy is measured in what unit? It's joules. So my answer here is 504.31 joules. Now I want to do one more with you here because when we talk about warm-up B, this is one. So this was kind of straightforward in the fact that we had an equation already solved for potential energy that we could solve that we could plug into. B is a little bit different because you're going to see that I have to pick a different equation. So let's look through B. What is the speed of a 900 kilogram car? All right, again, kilograms, what is that? Kilograms is a mass. So mass equals 900. With 304,000 joules of kinetic energy. So it tells me here it's 304,000 joules of kinetic energy. So I'm going to say kinetic energy. 304,000 joules. And what am I looking for? It says, what's the speed? Now you might say, well, I don't see any equations that have an S in it. Well, remember in speed, what is the term we sometimes use for speed? Well, that's velocity. Right, so V is what we're looking for. Now let's look at our equation. Our equation has a KE, an M, and a V in it. So if you look for the equation as KE, M, and V, it's this middle one. So I'm going to write that down here. KE equals 1/2 mv squared. Then I'm going to plug in my numbers. 304,000 equals 1/2 times 900 times v squared. Now this is just a little bit different because I'm going to have to do a little bit of algebra. So what I'm going to do first, I'm going to take my half of 900. So half of 900, remember in a calculator, half is 0.5. So 0.5 times 900 is 450. 450 v squared is 304,000. Now, how do you solve this? Well, I'm trying to get v by itself. It's going to be a multi-step problem. The first thing I'm going to do is get rid of that 450 by dividing both sides by 450. All that's left on this side now is v squared. And on this side, it's 304,000 divided by 450, which is 675.55555, so rounded to 2 decimal places, 56. Now, is that my velocity? No. That's my velocity squared. How do you undo a square? You square root it. A calculator to get a square root, if you don't remember, it's you press the second button and then this to get a square root. You want the square root of 675.56. And my calculator has given me 25.99. Now to finish it up, we need to put an answer with units. So this is the velocity. The units for velocity are meters per second. So my velocity is, I guess it is 25.99, and my units are meters per second. All right, there are 6 problems for you to work on today, and I'm expecting you to have it done at the end of the period and turn it in. Now, Mrs. Taylor is a math teacher, so if you need help solving these equations, if you get stuck, please don't sit there and not try. Do your knowns and unknowns. Talk to someone in your group if you need help, and then ask Mrs. Taylor if you need help, because she can point you in the right direction. All right, and then you will turn in this packet at the end of the period, and I will see you tomorrow. Thank you, and again, please be on your best behavior.